After removing this item, this front is also -1, rear is also -1. Otherwise, only the front has to increase. Linked list is a collection of nodes and each node contains two parts. One is data part and one more is address part. Whenever we have to delete the data, or especially here node, the node will be stored in some particular place. That particular place can be called as a while list. If I want to create a linked list, then we need a structure, because in the structure it is a collection of heterogeneous elements. Welcome back to one and all. Myself, Vasanta, lecturer in Computer Science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysuru. Today, we are going to start with 9th session of Data Structure chapter. Whereas, already in the previous session, you come to know regarding arithmetic expression, what do you mean by queue, types of queues, operation on queue, memory representation of a queue using array, memory representation of a queue using linked list. It means that what do you mean by queue? That is, insertion as well as deletion will take place at different position. Then on today's class, you will come to know regarding the algorithm for insertion, algorithm for deletion, application of queues, linked list, operations on linked list, creating a linked list, then the difference between new and delete operator, algorithm for traversing a linked list, as well as memory representation to a linked list. Then what do you mean by algorithm for insertion? Whereas already I told you, in a queue, insertion as well as deletion will take place at different position. The place where we are inserting an element, that can be called as rear of the queue, and the place where we are removing an element, that can be called as front of the queue. Whereas here, algorithm for insertion means we are inserting an element. At the rear position of a queue. Here, before writing the algorithm, first you have to mention which are the variables in the algorithm we are using. Whereas, let Q is the linear array of n element and front is the pointer that contains the location of the element to be deleted. The place where we are removing, that place can be called as front. And rear contains the location of the element. To be inserted. It means that rear contains the recent element, place where we are inserting. If I want to write the algorithm, first step, if rear equals n minus 1. What do you mean by this? Rear equals n minus 1. Consider a queue. On this queue, the position wise 0, 1, 2. If minus 1 represent front as well as rear, then it means that the queue is empty. Here, if I want to insert an element, first I have to check whether the rear is full or not. If it is empty, then front as well as rear contains minus 1. If it is full, consider the values position 0, 1, 2, here A, B, C. This 2 represents n minus 1. If we have rear equals n minus 1, it indicates that the queue is full. Here we are not able to insert any element. That is the thing. Rear equals n minus 1. Then it has to print that overflow. We are not able to insert any element. Then exit. Otherwise, if front equals null, or I can say it as minus 1 also, then on the 0th position, we are inserting an element. Here we'll insert. Then, when I inserted the element, this minus 1 is replaced by 0 here. This represents rear and 0 represents front. That's why if front equals null or minus 1, then front is 0, rear is also 0. Otherwise, consider we have only one element. If I want to insert, in the next case, the rear position will increase by 1. If it is equals to minus 1, only on that case, front takes 0 as well as rear takes 0. Otherwise, only the rear will increment. Then afterwards, new item will be inserted to the queue rear position, then return. This is the algorithm to insert an element in a queue, that is NQ operation. NQ is nothing but inserting an element at the rare position of the queue. Now is it clear? Next, we will move on to algorithm for delete an element. Whereas deletion of an element in a queue is called as DQ. Before writing the algorithm, first we have to mention which are the variables we are using. Where let Q is a linear array of n elements and front is the pointer that contains the location of the element to be deleted and rare contains the location of the element to be inserted. Now already I told you this is the Q. Here position wise 0, 1, 2. Here for example A, B, C. Then the 0 represent the front and 2 that is nothing but n minus 1 represents the rear. Okay. Then if I want to delete an element, first I have to check whether the queue contains some values or not. Whereas in the previous algorithm, if I want to insert any element, then I have to check whether the rare is n minus 1 or not, it is full or not, that way to check. If I want to delete any element, then I have to check whether the front, if it is equals to minus 1, then under flow, we are not able to remove any element. On this case, we have the capacity of the queue is 3, position wise 0, 1, 2, this front and this is rear. If I want to consider an empty queue, for example 0, 1, 2, here minus 1, this minus 1 represents the front, this minus 1 represents rear. In this case, we are not able to remove any element. If this front equals minus 1, then it has to print that under flow, no need to process exit. Otherwise, what it has to perform, whichever element in the front position, that element we have to remove. See, on this example, first in the front position, we have A. That element we will move to item. That is, whatever thing in the queue front, that we will move to item position. Once we have moved, then in the next case, the 0 represents front. Now this F represents 1 here. It has to remove the next element. Then after removing queue of front to item, if front equals rare, it means that for example only one element we have in a queue. Here only one element 0, 1, 2. This is the front and this is the rear. If I deleted this item, now what about the front as well as rear? Only on that case, if a front equals rear, then front equals minus 1, rear is also equals to minus 1. After removing this item, this front is also minus 1, rear is also minus 1. Otherwise, only the front has to increase. Hence, front equals front plus 1. Then finally return. Now is it clear for all of you? Next, we will move on application of queues, where exactly we are using queue concept. Whereas queues are used in different types of scheduling algorithm. Then it is used in round robin technique. Scheduling algorithm, what do you mean by this? Scheduling algorithm dividing the work or time in different manner. Whereas round robin technique, there also we are using queue concept, as well as it is used in various features of operating system. In the operating system, consider we have several jobs, all the jobs wants to process. On that time, this operating system will decide which one has to execute, like first come, first served, like that. Then it is used in multi-programming platform system also. Then it is used in printer server routines, different types of scheduling algorithm, round robin technique, various features of operating system, multi-programming platform system, as well as this queue concept is used in printer server routines also. Next, we will discuss about linked list. What do you mean by this linked list? When you come on array, array is a collection of homogeneous elements. Whereas, if you come on stack, stack is also a collection of elements only, but insertion as well as deletion will take place at different position. But when you come on queue, here also is a collection of element, but insertion will take place at rear position and removal of item will take place at front position. But when you come on linked list is a collection of nodes we used to say. Consider here we have starter point. This starter point contains the address of first node and here it contains actual information. then it contains the address of next node. For example, here I am having B. Then here I am having the address of next node. Here for example C, then here null. From this what I can identify? Whereas linked list is a collection of nodes, we used to say this is node 1, this is node 2 and this is node 3. Linked list is a collection of nodes and each node contains two parts, one is data part and one more is address part. In the data part, it contains the actual information and in the address part, it contains the address of the next node, which is the next node. Regarding that, it contains the information. If the address part contains null, it means that is the last node, whereas start contains address of the first node. Here, a linked list is a linear collection of data elements called nodes. It is a linear collection of data elements called nodes. And the linear order is given by means of pointers. Each node contains two parts. The first part contains the data and the second part contains the next node address. When we come on types of linked list, there are three types of linked list. One is single linked list, doubly linked list and one more is circular linked list. What do you mean by this single linked list? First of all, linked list is a collection of nodes, whereas each node contains two parts, data part and one more is address part. In the data part, it contains the actual data and in the address part, it contains the address of the next node. Three types, single linked list, doubly linked list and one more is circular linked list. When you come on types of linked list, the first one, single linked list. The single linked list contains a node, that node contains only two parts. One is data part and one more is address part. Here, in single linked list, it contains two parts. In each node, the data field and the linked field. This is the data field and this represents the linked field. The data field contains the data of the node and the link field contains address of the next node, which is the next node that address it contains. There is only one link field in each node, only one link we have. But when we come on doubly linked list, there we have totally three parts. One is previous node address and one more is forward node address and in the center part, it contains the actual data. Whereas in doubly linked list, each node contains three parts, the next node pointer, previous node pointer as well as the information. With the previous node, with the forward node address as well as it contains the actual information. But when we come on the third one, that is circular linked list. In this, the last node follows the first node or the first node follows the last node. That is, it contains the linking in a circular format. The last node contains the address of the first node. These are the three types of linked list. Next, when we come on operations on linked list, the first operation here we can able to create one linked list. We can able to create the linked list. Then we can able to perform traversing a linked list. That means visiting each node from the beginning one by one till the end. Then inserting an element into a linked list. While inserting, if I want, I can able to insert at the beginning as well as at the end also. Wherever we want, there we can able to insert as well as on whichever position there we want to insert as well as we can able to perform deletion operation. Then deleting an item from the linked list is possible. Then searching an item in the linked list. Whichever item we want, that item in the linked list we can able to search. Then merging two or more linked list. We can able to merge two or more linked list here. These are the major operations in the linked list we can able to perform. In the array also we have the operations like traversing, insertion, deletion like that. In stack also stack, push, pop, pick, is empty. In the queue also queue, enqueue, dequeue, is empty, size like that functions we have. In the linked list also we have creating, traversing, insertion, deletion, searching as well as merging operation is there. If I want to create a linked list, then we need a structure because In the structure, it is a collection of heterogeneous elements where the elements may be different data type. For a linked list, we need the data part as well as the address part. Both are different data type. That's why we are using the structure concept while creating a node. Whereas the node of a linked list can be created by the following structure declaration. First, we have to use the keyword struct, then node you have to mention. By that, I can able to create a node of structured data type. In this, we have the data part of type integer format, and here the node of star link format. That means it contains address of another node. In this example, we are creating two nodes, node 1 as well as node 2. Both the node contains the data part as well as the address part. Now is it clear? We will move on to the next concept, the new operator as well as delete operator. What is the use of new operator? New operator automatically execute when we need the memory, whereas the delete operator is used to deallocate the memory. Whereas new operator is used to allocate memory for an object dynamically whenever we need, dynamically from the memory while program is running. When the program is running, on that time, dynamically the new operator will allocate the memory. Whereas while writing the syntax, pointer variable equals new type. Here, when I am to write new type, then it is going to allocate the memory space. For example, int star ptr, then ptr equals new type. From that, memory can be allocated. And for example, if I want to allocate a memory for a list of elements, then we need pointer variable equals new type and then number of elements. Here, pointer variable equals new type 10. It means that for 10 variables, here the memory will be allocated. Whereas delete operator is used to delete the memory dynamically when the memory is not used. When we don't want, on that time, automatically it will delete by using delete operator. The syntax is delete pointer, whereas only one variable we can able to delete, whereas delete bracket then pointer if I am going to write. In the bracket, how many elements I am going to write? That many elements, that many objects can be deallocate here. While writing the example, delete ptr, delete 10 ptr. Now is it clear? Next, we will move on the algorithm for traversing a linked list. What do you mean by this traversing? Visiting each node from the beginning one by one till the end. Consider this is the starter point. This start contains the address of the first node. For example, here A, then this contains the address of next node B. Here we used to write null. Consider here traversing is nothing but first it has to visit the first node, then second node till the last node, one by one each and every node has to be processed here. Here start contains the address of the first node and P is temporarily used to visit all the nodes. Whereas here step 1 P equals start. Here this P contains the starter address. Then while P is not equals to null, it means that until this pointer address is not equals to null, till that it has to process the data part of P. What I consider now, this is P. Here it will process the data part of P and then P equals link of P. Whatever address in that, here there it will move to the next node. Like that, this loop will continue again and again until P is not equals to null. Once it is reaches to the null, then it will go to stop processing. End of while loop and then finally return. This is the algorithm to perform traversing in a linked list. Next, we will move on memory allocation to a linked list. What do you mean by this memory allocation? Whenever we are going to delete the data or especially here node, the node will be stored in some particular place. That particular place can be called as a while list. And whenever we want a node, on that time from the a while list only we are accessing the nodes. Whereas a while list contains only unused or deleted nodes. Whenever node is deleted from the linked list, its memory is added to the avoid list. Consider this is a place where when you want to delete the node, this node will come and store on this avoid list. Once again, if I want the node from this avoid list only, we can able to take the node. On that time, the node will deleted here in the avoid list. Whenever a node is to be inserted into the linked list, the node is deleted from the avoid list and inserted into the linked list. It means that avoid list is a place where we are storing unwanted deleted nodes. Once again, if I want the node, then from the avoid list only we are taking the node. And the avoid list is also called as free storage list. And this technique of deleting unwanted node or storing unwanted node is called as garbage collection. Now is it clear? Whereas this is nothing but memory allocation to a linked list. This is nothing but memory allocation to a linked list. Next class, you will come to know what do you mean by non-linear data structure, that is tree and graph, how exactly the data will store and which are the operations there we can able to perform. Regarding that, next class you will come to know. Thank you for all of you.